All right, so number one, and if you want to work ahead, that's fine. Okay, and just check your work. Totally up to you, or you can follow along with us. So that's asking for the solution of the inequality. So all we're doing here is we're just solving our one-step inequalities. Okay, so the one-step inequality, we're trying to get x by itself. How do I get rid of this negative 4? We're going to add it. What you do to one side, we do to the other. And you should have got x greater than 28. Just like a one-step equation, only difference is we have an inequality. Okay, and it's not asking us to graph, it's just asking us for the solution. All right, number 2, we have negative 3x less than or equal to 9. Okay, so what's my first step here? Or really my only step. What are we dividing by? Negative 3. So divide by negative 3. What did the one side do to the other? Remember, we divide by negative. We need to flip the sign. So divide by negative. Flip sign. All right, so all we have left is x. My sign flips. 9 divided by negative 3 is negative 3. And again, that one didn't ask us to graph, just asked for a solution. Okay. All right. Number 3. Which number line shows the solution set of this inequality? So for number 3, we're going to have to solve that. 5x plus 7 less than or equal to 32. Okay, so before we can determine that, we're going to go ahead and solve. So we have a 2-step here. All right, what do I need to do first in this 2-step? Subtract 7. And what we do to one side, we do to the other, Mr. Reed. That's right. Good job. So we got 5x. Bring my sign down. What's 32 minus 7? 25. And the last step here, number of variables side by side means multiply. Divide by 5. Divide by 5. And x is less than or equal to 25. So when we look at those graphs, is it going to be an open or closed circle? Closed because it's equal to. So it could be C or A. And since less than, why did I put 25? Good 3. X is less than or equal to 5. Less than 5, so we're going to have A because it's less than. Four, solve and graph the inequalities. We're going to have to graph this one as well. So 2x minus 9 less than 11. First step here is to add 9 to both sides. So add 9, add 9. All we're left is over here is 2x. Bring down my sign. And 11 plus 9? 20. Last step. Tough crowd. Divide by 2. Do to one side, we're going to do to the other. Do I flip the sign? No. X is less than 10. And we have to graph it. So again, when you graph, what I would do is just put your answer in the middle. Go one to the left, one to the right. He sticks his tongue out. Tells me the arrow goes to the left. Open or close circle. open. There's no pen underneath here to fill it in. There's no greater than, or there's no equal to. Let me shade. If I'm going too fast, you need me to slow down, just yell at me. Number 5, which graph represents all of the solutions of, we got a nice big long one there, 122 less than or equal to 6 minus 4 times 6n plus 7. Now this is one of those that, like I said, some of you might get overwhelmed just because this is a bigger problem. All right, so go through your steps. Look at my parentheses. Can I simplify inside of here? No, I don't have any exponents. So now I'm looking at my multiplication. So here's my question to you. And this is your property. Are we distributing a 4 or a negative 4? It's a negative 4. That sign in front of that determines that. Okay? That's a negative 4. So I want to distribute it here. What's negative 4 times 6n? Negative 24n. Okay? Don't automatically write that plus sign down. What's negative 4 times 7? So if I write negative 28, do you see how that determines my sign for me? Okay? It automatically puts that subtraction sign because it's a negative. Okay? That'll help you a lot. And then bring everything else down. What do I do next? You don't have to raise your hand. Combine my like terms. So I have a 6 and a negative 28. When I combine those, what do I get? Negative 22. And then bring down my minus 24n. Bring down my sign and my 122. Now I have a 2-step. So what do I do next? Good. Add 22. Add 22. And we get 144 less than or equal to negative 24n. Last step. Divide by negative 24. Divide by negative 24. What happens if I divide by a negative? We flip that sign. What's 144 divided by negative 24? Are you sure? Okay, I trust you. Negative 6. Flip my sign. In. So which graph works? Is it a open or a closed circle? Closed. So all 4 of those are closed. And we're looking for a negative 6. So it can't be D, can't be C, could possibly be B, can't be A, has to be B. So it has to be B. B. Any questions on that one? No? We good? All right. Sign up. 6. 6 is asking us to graph the following. Negative 4 less than or equal to x less than 6. Okay, we're going to graph this. So what I would do on this graph, first, just try to use common sense. Okay, negative 4 and 6 are pretty far apart, right? So your line needs to be kind of big. I would put negative 4 on this side, 6 over here, and then we're going to fill in between. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. 4, 3, 2, 1, 0. Okay, so look at your signs. We're going to have 2 different types of circles. Okay, so a negative 4, is this going to be open or closed? Closed, because it has an equal to. And then on my 6 is going to be open because it's not equal to. Okay? Now, read these separately to yourself. Okay? So if I read from x to negative 4, x is greater than or equal to negative 4. Okay? Numbers greater than negative 4 are those to the right or to the left. Is negative 3 greater than negative 4? Yes, so those numbers are to the right. Okay? X is less than 6. That means it's smaller than 6. So numbers smaller than 6 are to the left. So if I do draw these little arrows up here, they tell me which direction to shade. This means I'm going to shade in between these numbers. So your graph should have an open circle on 6, closed on negative 4, and shade in between. Okay? Be careful when you're reading your signs to yourself. Now, what else you could do is you could go right here and you could separate these. So you could have x is greater than or equal to negative 4, and x is less than 6. If it's easier for you to read them like that, separate it and read them and then graph them. Okay? Again, that's just a tool you could use that could help you. All right? All right, let's look at 7. What are the solutions and graph of the absolute value of negative 9b less than or equal to 27? If you watched the lesson from Monday, you will know how to do this. If you didn't, pay close attention. We have absolute value. Remember, we have to set this equation equal to 2 solutions, okay? What we're going to do, if you remember, we're going to have negative 9b less than or equal to 27. What do I put on the left side here? I'm going to put the opposite of this solution, negative 27, and I copy the sign, okay? So now I have 2 different answers on both sides, and I'm solving on both sides. We can either solve this like this with this all together, or I can split it. All right? So we'll solve it together first, and then I'll split it, and you determine which way is the easiest for you. Okay? Yes?
I thought you would just divide 27 by.
But you can't because it's the absolute value.
Oh, I thought you just drew the line.
Oh, you thought I just drew lines because I felt like it?
No, I thought that's the value, so just put it from 0. So
It is, but when we have an absolute value of a function, then we have to do this because your answer, what goes inside of here could be positive or negative. Because remember, absolute value of negative 7 is 7, but the absolute value of 7 is also 7. So 7 has 2 absolute values. So when we do this, okay, it's just like an equation. I would divide by negative 9, and what you do here, you have to do both sides. What did I divide by? That is a very, very, very important thing I need to remember. What do we divide by? A negative, okay? We divided by a negative. So we divided by a negative, flip both signs, okay? So that means this sign will be greater than or equal to. This sign will also greater than or equal to. And then negative 27 divided by negative 9 is 3. All that's left in the middle is v. And this over here will be negative 3. Okay? So there's your answer to this one because v is by itself. Now, here's another way to do this. And this might be easier for a lot of you. We can split this. Okay? So if I have negative 9v is greater than or equal to, notice I'm reading it this way, negative 27. And then I'll also have, read it this way, negative 9v is less than or equal to positive 27. Okay? And then I would solve both of these equations, or I'm sorry, inequalities. divide by -9, flip my sign, b is less than or equal to 3. Same thing here, divide by -9, flip my sign, b is greater than or equal to -3. So we have the same answer, it's just two different ways to do it. Okay? So if you're comfortable doing this, by all means do it that way. If this is very confusing to you, split them up and solve them down here as two separate inequalities. And then when we graph, I'll put my 3, my -3, 2, 1, 0, 1, 2. And I have, since they're both equal to, they're going to be closed circles. Okay, so b is less than or equal to 3, so it's going to be less than 3, but it's greater than or equal to -3, which means we're going to shade in between. Number 8. What are the solutions of the inequality? So we have 6 less than or equal to x plus 3 less than 10. So we have a compound inequality. And again, this is just like what we did on 7. You can either work it with it all together or you can split it, whichever way is easiest for you. Some of you give me those big old eyes like, whatever's easiest for you, okay? So what we're going to do, just like we solve any inequality, I'm going to subtract 3 from both sides. All that's left in the middle is x. Bring down my signs. I didn't divide or multiply by a negative, so my signs stayed the same. And 6 minus 3 is 3. 10 minus 3 is 7. And then we would graph. So I'm going to have a 3 here, 7 here. 3 will have a closed circle because of the equal to. 7 will be open. 4, 5, 6. And then we just kind of read these to ourselves. X is greater than or equal to 3, which means from 3 it will go this way. X is less than 7, so it's going to go this way. We're going to shade in between. It won't always be in between though. Just keep that in mind. So open circle on 7, close on 3, shade in between. All right. Any questions on those? We're good? Confused? Wish I would hurry and get done with this. You're tired of listening to me? Like which one? Awkward silence it is. Okay. On to 9. Graph the following inequality. So -3 less than x less than or equal to 5. So if you start at x, like I've been telling you, and read them to yourself, x is greater than -3, okay? So if it's greater than -3, if a number is greater than anything, it goes to the right, okay? And then x is less than or equal to 5. So if it's smaller than 5, it's going to shade to the left. So when I draw the number line here, -3 here, 5 here, I don't think I made this big enough. 2, 1, 0, 1, 2, 3, 4. Yes, I did. Open or close circle on 3.
Open.
Why? It's not equal to. Open or close on 5.
Close.
Close, because it's equal to. If I look at my arrows, they're telling me to shade in between. That's what we're going to do. I'm going to shade in between. Number 10. A compound inequality is shown below. Sweet. Simplify the inequality. 4 less than 1 minus 3x less than 14. So again, you can split this if you want to, but if you don't, you can just work it as is. Okay. First thing I get rid of here is my 1. How do I get rid of that 1? Subtract it. You won't believe how many people would say add it because they would look at this sign here. Okay. So we would subtract it. All right. We would subtract 1 here, subtract 1 here. 4 minus 1 is 3. I don't flip my sign because I didn't multiply or divide by a negative. All that's left in the middle is negative 3x. Bring down my sign, and 14 minus 1, 13. Last step here is to divide by negative 3. What we do here, we do to both sides. Divide by negative 3, divide by negative 3. We divided by a negative. What does that mean with my sign? We flip it. Flip this one, flip this one. So we have x in the middle. 3 divided by negative 3 is negative 1. And 13 divided by negative 3, we don't know. So we'll just leave that as a fraction, negative 13 thirds. And that'll be our solution. All that says there is to simplify the inequality. All we had to do was simplify it. Didn't have to graph there. Number 11. Ooh, word problems. Those are your favorites. Oh, yeah. The cost of renting a boat is $25 plus $2.25 per hour, where X is the number of hours of boat rental. Nellie wants to spend less than $40 on the boat. Write the inequality that models the situation. What are some key words in there? Yes. Per hour, where X is hours. So I know that that's going to be $2.25. The word per means to multiply. Okay. Hours and X is the number of hours. Okay. So if you have to write down X equals hours, you can write that down if that's something that helps you. Okay. Another key word is the word plus, because it says $25 plus. So we're adding $25 to our hourly rate. Okay. What else is some key words in there? Less than 40. That's how much. That's what she wants to spend. So she wants to spend less than 40. And the reason I write it like that is 40 out of these two sides should be the greatest number. Okay. Because we don't want to spend any more than 40. So we've used our keywords to set up our equation, or not our equation, our inequality, and now we're just going to solve it. No, take that back. We're just going to write it. See, I almost made a boo-boo. I didn't read the directions. What's the directions say? Write the inequality that models. All you have to do is write it. How many of y'all would have solved this? I would have. Not gonna lie, I was getting ready to. So I got two honest people in here. Me and Peyton. Everybody else had them hands down. Yeah, it's too late to raise your hand now. Too late. Huh? Yeah, I didn't see it. Anyways. All right. 12. Nathan is taking a mathematics test, must answer at least 20 problems correctly to earn the grade he wants. Nathan knows he answered 7 of them correctly and uses C to represent the remaining problems he must answer correctly. Write inequality that best reflects the situation. So he needs 20 questions to get correct on this test. So is 20 going to be a part of the solution side? Or is it going to be part of the expression size. $20 is not $20. 20 questions is basically that's our point. Okay, that's our point we either want to reach, go above, or stay below. Okay, so my 20 questions, I need at least 20. So can I have less than 20? No, I need at least 20. Okay, so 20 needs to be the smallest number, which means the alligator is going to want to eat this side. Can I have exactly 20?
Yes.
Yes, so I can have equal to 20. All right. So you see how I'm kind of walking myself through this, giving myself little scenarios. I know it's not mathematical and it's not professional, whatever, but talk yourself through these problems sometimes. Sometimes being goofy can help you get there. Okay. Now I know for a fact I answered 7 of them correct. I got 7 right. So when it says use C to represent the remaining problems he must answer correctly, basically means how many more do I need to get correct to get to 20? So what operation is going to go between 7 and C? Plus. We're going to take the number we know we got correct plus how many we need to get correct to get to this number. Okay? Now, before this started, you might have looked at this and thought this was going to be some big complicated one. But it's really just 7 plus how many I need to get right should be greater than or equal to 20. And again, the directions say write inequality. Doesn't tell us to solve it. Okay? 13. What is the solution for this equation? Now, this is what we did Monday. We have absolute value equations. Okay. So if you watched the notes on Monday, like I know everybody in here did, like you were supposed to, good job. What do we set this equal to? With absolute value, I know that I'm going to have 2 different answers. Okay. So we're going to have 3x minus 4 equals 11. 3x minus 4 equals negative 11. Okay. You're going to set what's inside the absolute value bars equal to your positive solution and your negative solution. And then you're going to solve because the absolute value, you have 2 different answers. The reason is, just like somebody said earlier, absolute value is a distance from 0. How many sides do you have on a number line on 0? You have 2 different sides, right? You have your negatives and your positives. So that's why we have absolute value. We're going to have 2 different solutions. Okay? So you're going to have a positive and a negative, and then we're going to solve it. So for this side, we'll add 4, add 4. All you're left with is 3x equals 15. Divide by 3, divide by 3, x equals 5. That's one solution. Then we're going to come over here and we work this one. Add 4, add 4. All you're left with is 3x equals negative 11 plus 4 is negative 7. Divide by 3, divide by 3, and we're going to leave it as a fraction. X equals negative 7/3. Okay. Don't feel like you have to work that out or put that in decimal, put it in mixed numbers. Okay. Just leave it as a fraction. That's totally fine with me. Yes. I think 240. Maybe 230. I can't remember. Are you that bored? You're asking what time you're leaving my class? Jeez. Anyways. 14. Same thing. We have x plus 8 equals 15. When we have absolute value, we're going to have x plus 8 equals positive 15, and x plus 8 equals negative 15. And then you would solve both of these. All right. So we're going to subtract 8 from this one, subtract 8 from this one. X equals 7. Subtract 8 from this one and this one. X equals No. Negative 15 minus 8. Huh? Good job. So your solutions here should be 7 and negative 23. $15. Solve 5x plus 7 equals 18. We just have a two-step equation, okay? What do I get rid of first here? Subtract 7. What we do to one side, we do to the other. All that's left over here is 5x equals, what's 18 minus 7? 11. Then we're going to divide by 5, divide by 5. We're going to leave that as a fraction. X equals 11 over 5. $16. If C plus C plus C equals 45, what is the value of C? What would you do first here? Where'd you get 3 from? You skipping on me.
Well, there's 3 so it's 3 plus 3 plus 3, so it doesn't equal 3.
It's not 3 plus 3 plus 3. It's C plus C plus C.
Oh, that's not what I meant. I had 3.
So you combine like terms. 3C equals 45. Divide by 3, divide by 3, and C would equal 15. Good observation, though. $17. So we have 4x plus 2 equals 97. Two-step equation again. What do I get rid of first here? The 2. So I'll subtract 2. What do one side do to the other? We have 4x equals 97 minus 2 is 95. And then what would I do? Divide by 4. Once you do one side, we do to the other. And x equals 95 over 4. There you go. $18. We have 75 minus 3 times x plus 4 plus 4y. When x is negative 3 and y is 11. Okay, so here's kind of like the easiest way I personally think to do this. Everywhere there is a variable, I would insert parentheses. Okay, so what I mean by that, I would write 75 minus 3. There's an x plus 4 plus 4. Okay, and wherever there's parentheses, then you would insert whatever your variables are. I know this probably seems like you shouldn't have to do this. Like, no, I don't know why you're making this extra step, but you don't have to use it. But some people get really confused with these type of problems. Okay, x is negative 3. I put my negative 3 here. Y is 11. I put my 11 here. And the reason why I use parentheses is because when you have a number and a variable side by side like we have here, this will show you to multiply. Okay, I promise you, I have had people who would just put 11 there and then they work this problem as if it's 411. It's happened. That's why I always say, hey, put parentheses, please. It shows you multiplication. Okay, so then you're just going to go through your good old-fashioned order of operations. All right, so inside of our parentheses, negative 3 plus 4 gives me 1. And what's 4 times 11? Then I'm going to have to do my multiplication here. What's negative 3 times 1? -3. And then we're just going to combine these. So 75 minus 3 is going to give you 72. And then 72 plus 144 gives you what? 116. Final answer. Final answer. All right, 19. I've had a bunch of people who've had trouble with these proportions. Finally, we get to teach these in person. Maybe we can clear some things up. So with your proportions, if you have expressions in your fractions, go ahead and put parentheses around these because that's going to show you that you're going to work these like distributive property. We're going to cross multiply. This is 2 times x plus 2 equals, cross multiply here, 4 times x plus 5. Okay, so we've cross multiplied for these in parentheses to kind of help us out. And then we're going to do our distributive property. So 2 times x will give me 2x. Then 2 times 2 gives me positive 4 equals 4 times x is 4x. And then 4 times 5 is positive 20. And we have variables on both sides, just like a, yes.
So, like, what job will we actually use that?
When you have to think.
That's what jobs we use.
Well, then you're going to struggle with a lot of jobs. I mean, you could think like, all right, construction, for example, building trusses. Trusses are tons of proportions. Because when you're doing trusses, you have to make sure that certain pieces are proportional to the other. X, you're never going to write this down on a job site and write down X and solve this, but this is how your brain thinks. So we're teaching you how to think. It's not that you're going to go somewhere and they're going to say, here's this equation, solve this to do your job. No, like for example, you got $10, and let's say you go over here to Kroger and they got candy bars on sale. They say, hey, Milky Ways are 2 for $1. All right. Your mind is going to use variables, but you're not going to write down X. You're going to say, well, if I get 2 for $1 at $10, well, I know I get 10 sets of those. I get 20 candy bars. But the equation would say 50 cents is 1, so 50 cents times X equals $10. That's how you would solve that if I was to mathematically write it down. But this is just a way to think. But like I said, you're not going to be on a job site and go, oh, hey, Billy, here's X. Solve this so I know about this lumber back here. No, you're just going to go back there and figure it out, right? We're just teaching you how to think and how your brain works. Does that make sense? I had a kid one time ask me a question, or we was doing math. He goes, I'm going to use in real life. So I asked him what he wanted to do. He said, I want to be a welder. He said, you don't use math and weld. And I said, I'm never coming to you, ever. Because you're going to have to measure something to weld on. You know, how big this piece of metal needs to be. I need to weld between this and this to make this work. I'm like, so if you're telling me there's no numbers, I'm definitely not coming to you at all. But good question. Good stuff. All right, so I'm going to get my variable to the same side, and I like to work to the left. I know it's going to give me a negative, and I'm fine with that. But if you like to keep your variable positive, you can work from this side to this side. That's fine too. So if I subtract 4x, what I do to one side, I do to the other. I'm going to get negative 2x. Bring down my plus 4 equals 20. And now I have a two-step equation, and we just go to work. So we subtract 4, we do to one side, we do to the other. Negative 2x equals 20 minus 4 is 16. 5 by negative 2, 5 by negative 2. And x will give us negative 8. Any questions on that? All right, so let's look at 20, 21, 22, 23, 24, 25. Any of those you all feel like you would have trouble with that you want me to go over? Because the rest of those are just review.
20, I don't understand what it's saying.
Given the replacement set, it's giving you four numbers, what must be to make the sentence true? So basically, they forgot something there. What must n be to make that true? So which one of those four numbers can I plug in for n to make that statement true? Is what it's asking. It just forgot to write that, to put the n in there. So 21 would be, you're going to tell your solutions. 22, you're going to write your own equation. 23, you're just solving a two-step and you're describing the step, but your math is your description of the steps. And 24 and 25, you're finding the incorrect steps there. Okay.